There's more than one way to approach this problem. One is you could say, oh, it's a sine function. Okay, so I'm just going to graph a sine function like this, and then I'm just going to figure out everything about this sine function. Or you could start with a sine function and do all the appropriate shifts. And if you do that, you're going to end up with more than one period, which is fine. It says graph one period. You can always do or more. Okay, so I'm going to try doing it one way, and then I'll show you the other way. So I'll give you a couple options this way. So if you just have a sine function like this, you have 3 times sine of something, and it's minus 2. So the height, if it didn't have a minus 2, would be 3. 3 minus 2 is 1, so the highest point is going to be 1. And so you've got minus 5, because you have minus 3 is the lowest it can go, minus 2. So the lowest it can go is minus 5. And this midline here is minus 2, right? So you have a 0 here, negative 1, negative 2, negative 3, negative 4, and negative 5. That's what your essentially your y-axis looks like. And so the question is then, where is this starting and ending, and all that jazz. Okay, so for a sine function, you need to know sine of minus x is the same as sine of x plus pi. So what that means is for a sine curve, adding pi to your angle is always going to make sine negative. And there's a really easy geometric way to understand why this happens. You don't have to think about it as a formula. If you have a unit circle like this, wherever you are, let's say you're here, and you add pi, you're going to end up over here, right on the opposite side of the circle. And you see your x and y are going to be the same magnitude, but x is going to become negative, y is going to be the same. And so that'll change the SIGN of the SIN. It'll change the sign of the sign. Let's see, what if we were, say, like up here, and then we'd end up down here. In this case, we're changing x from being positive to negative, and let's see, y was positive and now it's negative. So, but it doesn't matter because r is what matters. R is not going to be negative, right? So all that matters is no matter, whenever you travel pi around the circle, you're going to change the SIGN of the SIN, always. So if that makes sense, then this whole expression here could be 3 sine of minus 2x. Which is the sign, same as putting a minus out front. Right? Okay. Right. Okay. Okay, so this has been shifted. So let's think about this. If we put in 0, sine of 0 is 0, right? For x. But then if we put in, so normally the period would be 2 pi. But the period is just pi. Plain and simple. Okay, but now we're shifted. So actually, this is where 0 is now. And this is going to be pi over 2, and this is going to be minus pi over 2. If you just did this much, this would be full credit, right? Because it's not completely full credit. You have to say minus pi over 4. I would probably give you full credit anyway. But this is pi over 4. There you go. And so then you've labeled the max and the min because you know the max is right here. So that's at minus pi over 4 comma 1, and this guy is at pi over 4 comma negative 5. We've labeled the max and the min. And technically, these guys are, well, they're not absolute maxes and mins, but they're relative maxes and mins because the function got cut off. Alright, so that's one way of doing it. Let's say you don't think that way. Let's try it another way. Okay, so let's try taking the thing and shifting this thing around. Okay, so we have sine of 2x plus pi. And what we want to know is 2x plus pi. We want to know what x is at the beginning of its normal period. Okay? In fact, I'm gonna shift this over. So I'm only gonna graph like 2 periods of it instead of 4. Like in the answer key that I posted, I graphed 4 periods of it, but that's too many. So 2x plus pi is equal to 0 when what happens? Minus pi over 2. And then what happens? 2x plus pi is equal to 2 pi if 2x equals pi, so x equals pi over 2. Okay, so the period that you're normally expecting, I guess we're getting back to the same picture we got before. So I haven't really shown you a new way of doing it if I do this. But maybe I'll show you 3 ways, I don't know. There you go. Okay, so if I go from minus pi over 2 to pi over 2, this is where my normal sine curve lives. But then I have to go minus 2. I got to drop this thing by 2. And I have to multiply it by 3 first. So again, this is where I'm going to end up with 1 times 3. I'm sorry. Yeah, the height of sine is 1 times 3 minus 2. So the height could be 1 here. Instead of making this the axis, this is not the axis anymore. This is the line y equals the midline, or y equals -2. And then this guy is -5. And that means the axis would actually be somewhere up here. If I'm going to do that, I guess I should change the color of this guy to something else so it doesn't look as distracting. There you go. Does that look good to you? Or you could even erase that line. There you go. Does that help? Alright, fine. Let's try it one other way. Kind of like a hybrid. This was a kind of a hybrid approach. Okay, so you're going to look and you're going to see that x is getting multiplied by 2. So the speed is, twice speed of the usual sine function. So you know that the period is going to be half the normal period, or the period is going to be pi. It takes pi to go all the way around. But this thing is going to tell you you're going to shift by 180 degrees. Okay, as we already discussed, or multiply by -1. Same thing. So maybe what you want to plot is this guy. Alright? Move this guy up. Okay, then what we want to do is we want to look and say, what is going on here? Sine of 2 pi. What would sine of 2 pi be? So normally, let's say if we go from -2 pi to 2 pi, this is going to end up being 4 periods, so hang in here. Normally, this would be 1 period from 0 to 2 pi, but it's actually going to be 2 complete periods. And that means we're going to have 2 complete periods over here as well. That's kind of messy, but that's what it is. And then what we're going to do is we're going to multiply by 3, so it's like, oh, okay, maybe this is 3, and this is -3. But we forgot to multiply by -1. So we're going to basically say, oh, all this was wrong. We're going to have to multiply by -1. So let's go ahead. So you're going to flip this guy and flip this guy. You're going to get 2 more copies over here. Okay. Now you're going to drop it by drop it by 2, drop down by 2. So then the whole curve is going to drop. In other words, this axis is going to come up. So the curve just dropped, and then these coefficients are going to change. Like we said before, that's going to be -5, and that's going to be 1. In any case, you have to label max and min values, and if you draw this many periods, that's a pain, right? But anyway, you have to at least label 1 max and 1 min, because if you did a period, you would always include 1 max and 1 min in any one period. So since you were requested to graph 1 period, you have to at least label 1 max and 1 min. And so you have to figure out where all those are. And so the way we've drawn it now, it's kind of confusing, but this is 1 period. From here to here is 1 period. And so that's actually pi right here, and halfway through is pi over 2. So this guy is going to be pi over 4, and then this one's going to be 3 pi over 4. So you can say a max is 3 pi over 4, comma 1, and a min is pi over 4, comma -5. Okay, so any of those techniques are fine. Your answer is going to look a little different, and you know, based on how you approach this problem. But when I'm grading this kind of problem, I'm going to look to see that either by, you know, shifting, so like for example this pi, you have to figure out that you're either shifting the graph or you'll figure out that you're multiplying by -1. So those are 2 different things you could do. But other than that, you have to understand that by replacing the x with 2x, you're doubling the speed. You have to understand that by multiplying by 3, you're stretching it. You have to understand that subtracting 2 means you're going to drop the function. Okay, so those are the basic things I'm going to look for. And if you hit those points and you label their max and min, that would be full credit. And that it may look different, slightly different on your page. And of course, you can always ask Wolfram Alpha to plot this. It has no trouble. You just write pi for pi, and everything else is pretty much what you think it would be. Okay.